everybody. Thank you very much for joining me here today. This is Paul Taubman with 9.Connects, and you are in the right place if you are here for our webinar, as we initially titled it, Beyond the PCB LIB, the Advanced Techniques for Footprint Creation. And the reason why we said Beyond PCB LIB is because the vast majority of things I'm going to show you today aren't going to start in the PCB library when it comes to making custom footprints. So that's what we're going to start off with over here. Some housekeeping notes. I don't think I might have questions for you. Time for questions at the end. My runs of this earlier before we broadcasted here today, they've been running about 50 minutes. So I don't think I'll be able to get questions. However, please do write questions because I'm more than happy to try to answer those afterwards. So if you are going to put down a question, you have a questions panel with your GoToMeeting, feel free to use that. But please do be specific so that I'm not trying to answer something that's incorrect or not answering what you wish to hear. For those who may be new to Altium Designer, I don't know how many of you are brand new to Altium Designer or somewhat new to Altium Designer. What I'm going to show you today is what is called the last resort. So normally, I'd say out of 1,000 components, 999 of those are probably going to be done through either the wizard or you're just simply going to go into the editor, put down a couple of pads, and then through copy and paste and symmetry, you're probably going to be able to put that together by yourself. These are really unusual patterns or shapes that are just going to be very difficult for you to draw out. I'm not saying impossible, but they'd be remarkably difficult. So we would, you'd probably want to try these other techniques I'm going to show today, but this is not the normal procedure. All right, with that being said, my objectives, first and foremost, want to talk about these, what they call touch libraries, the MTouch, QTouch, and Cypress, I think they call it the CapSense library. So we'll talk about those that are in your Altium Designer, actually been in Altium Designer since 2011, as far as I remember. To demonstrate the DXF DWG import strategy, I think all of us have struggled with this, so I do have a couple of tips and tricks that might make it a little easier for you to get it right, possibly the first time, if not, at least get it right the second time that you try to import something in. But I've got a couple of strategies I think you'll find useful. Then we'll demonstrate the custom footprint creation and show you how we go about trying to create this footprint. And of course, DXF DWG is going to be really important to this because a lot of times we're getting something from the outside, some MCAD program. We bring it in and now we want to kind of flood it with copper. And I'm going to show you how to do that and then ultimately bring it into the PCB library. And then lastly, talk about scripting and show and provide some details. And so I'm definitely not going to talk about scripting itself. That's a dragon I have twice tried to slay and both times got pretty burned with it. But I would say that there are people who know how to script out there, and there's ways of getting those scripts because the Altium community is very generous. And so I'd like to talk about that and also kind of show you the procedure for running a script, because a couple of months ago I received the script. I thought it was broken, but come to find out it was a procedural error on my part. And so I want to make sure that you avoid the same mistakes that I made in trying to run that script. And then a couple of cleanup notes thereafter when it comes to creating something with a script. And so that's what I got here, but I do have a polling question for you. So we're going to bring that one up. We're going to first start off with these this touch library, the MTouch, the QTouch, and the CapSense libraries. And I'm kind of curious to know if you guys have ever played with it, seen it, used it. And so we'll put that up here right now. All right, yeah, this is kind of what I figured. I'm actually surprised to see that 3% of you have actually designed with them. I'd be kind of curious to know afterwards your experiences with them. But the vast majority of you didn't even know you had them, or you knew about them, but really never went beyond just that particular understanding. I'm going to show you guys one more. I'm going to just push through this really quickly. I'm going to show you one more PowerPoint slide, then we're going to jump straight into Altium. So in talking about these sensor libraries, the reason I brought this up is because the other day I was installing Altium 22, and you may have noticed if you have done an installation of Altium, this always comes up, right? Just before you fire it off and they show you all these different things that you can install. Well, the libraries we're going to talk about today, this is what this little checkbox is for, because this is a very, very unusual library. This library does not have a traditional footprint library associated with it. The footprints are actually made during the ECO process. And that's what makes it, and that's why they have this additional extension that they ask if you want to install it. Now, for most of us, we probably say, look, this thing's already big enough as it is. I don't want to bother with it. So you probably didn't turn it on, but that's okay because we can enable it afterwards once you have Altium Designer installed on your machine. And that's what I'll show you here in just a moment. Now, with that being said, I'm going to bail out of my PowerPoint presentation and let's go take a look at Altium Designer. So these are the libraries. I've taken the liberty to take each one of them and put them onto a single sheet. There's one for MTouch, which is microchip. There's one for Atmel QTouch, and there are a series of libraries for the library components for the Cypress CapSense. So how do we get these libraries to show up? Well, in the top right corner, if we put our cursor there and you go to the little drop down, you'll have something called extension and updates. So we're going to go over to that. So make sure you're on the extension updates tab. You don't have to purchase it, meaning that you don't have to install it because it's already been actually installed on your machine. It just has not been enabled. So you really want to be in the installed tab in order for us to gain access to it. And we're going to click on this configure button that's here on the top right. Scroll all the way down, and then you will see the touch sensor support, and then you just enable this. Altium's going to come back with a little notification stating, hey, you're going to have to restart Altium in order to gain access to the libraries for this. So once you've done that, the next step is to actually install the libraries. So how do we do that? It's really through the traditional approach of going to the components panel, going to the button that's called operations here on the top right corner, clicking on it and going to file-based library preferences. So these libraries are in the public documents. So if you go to public documents and you go to Altium and then the version that you're using, you'll find a library there. And then within that library, you'll find the MTouch, QTouch, and CapSense libraries. So just to demonstrate that here, I'll press install. I already have them installed, but let's just go through the motions of that. So here we go. So I am using Altium 21 for this. And if you just go to, again, if you go to your public documents, because most of the time when we install this, we install it, and it usually gets installed in public documents unless you've changed that otherwise during the initial install. Then you go to Altium, and then you go to the version that you're going to use if you have multiple versions on your machine. In this case, again, I'm using 21. Simply because when I started putting this webinar together, I was working in 21, and I just preferred to stay with the devil you do know than the devil you don't for this. But I'm fairly certain this would work in 22 as well. So you go into library, and then at that point, you go to either CapSense, MTouch, or QTouch. And of course, if you want all three of them, you do have to do this 3 times. And just one little side note, sometimes this might be set to something else here at the bottom. This is the filter for the files. So it is an integrated library, but if you have all files, then you'll always be able to see which libraries that are available there. So you just press open, and that would add it into your installed library path. So there you go. All right. So now that we have that installed over here, it's just a matter of going to your drop down in the components panel and then picking one of these here. So let me just pick the Atmel one just because it's where my cursor is. And these are the things that are available there. Okay, and so it's just a matter of just opening up a, actually, did they add a few more of these, or did I switch these out? Well, anyways, here they are. In fact, I think they may have switched this out. I think this is the Atmel QTouch, and this one's probably the CapSense one, so let's put these properly there. There we go, little clean up there. All right, but nevertheless, that's what you do. And you take these and you would add them onto your schematic the same way you do any other component. So where do we get to configure the footprint? Well, that's what's kind of interesting about this. And it doesn't matter which one of these I pick. But if I click on this, let's say this microchip MTouch, and I right click on it, at the very bottom, you'll see configure. And so when we bring this up, it brings up this dialog box for us to configure it. So this is what the basic shape of it's going to be. So now it's just a matter of changing the width of it, or the gap width, or the slider width to it. One of the other things they did, which was kind of interesting, is that for the same family, let's say this is not really the one I wanted to use, I can actually do a little drop down here. So within the family, there are 3 parts. So I can actually change out to another part. And so if I go here to the chevron slider, well, now it brings up the configuration for that one. And I would just simply press OK. In this case, I'll press OK. And as a matter of fact, you may have noticed that they've got the little representation of what these footprint patterns look like over here. And this one did change, and it will change it. It will update it. So if I go back to this one, just to show you that, if I go here and I go into the chevron slider and I go to the linear slider here and I press OK, it changes it back. So that's how this library works. So when does the footprint actually get created? It gets created when we do the ECO process. So if we go into tools here actually, pardon me, if we go to design here, and I'm going to use this particular PCB dock for the ECO process, I'm going to click on this, right? And I am going to turn off a few things here. I'm going to turn off these two because I really don't care to have them on here. And I'm going to execute the changes. And when I do this, then we'll see all the cool little footprints that get created here off to the side. So that's why I put these all together, just to kind of show you what they are. And some of them you're going to look at and you're going to be like, I can make that in the library. And that's very true. But if there's some of them here, they are pretty complex. And the thing, and what they realized with this, and this is one, let me change the color here so we don't have to look at all these error markers. There we go. What they realized with some of these things is that, yeah, you could probably draw these out. The problem is that you may have to change them as you're going along, saying, oh, I don't have enough channels on this, or I need to change the gap on this. And all you need to do in order to do that is you just go back into your touchpad, into your schematic design, and you just reconfigure it, and then you just do the ECO, and it'll swap it out. It'll create the new one automatically for you. So a very nice feature for that as well. So they want to make it as easy as possible to use these things, because one of the biggest complaints they had when this whole concept came out is that making these footprints was really difficult. And so that's why Altium worked with Microchip and Atmel and Cypress to come up with these custom pads. And you can only imagine the library, how large that library would be if they had to do it through the traditional method of keeping footprints, as opposed to just building it on the fly. Now let's go back over to that library here for just a moment here and just kind of poke around, because you can see some of these are pretty cool and they're very complex. So what do they really do here? What's the algorithm doing? So let's take a look and just break this down for a moment. So I'm going to click on this one, and I'm going to go into its properties. And in the properties, I'm basically going to unlock the primitives. And of course, it's not a very good practice when you're doing this in a design. Sometimes you do have to do it, but I'm going to unlock it here just to demonstrate something. So what do they make this of? Well, if I click on this over here, you'll see that this is made of a region. Right? So this would be something that you could draw it in Altium, but it would not be easy to do. Right? But what you're going to learn, if you don't know this already, is that regions don't have designators. And because they don't have designators, you can't have a pad-pin relationship with them. Well, that's kind of problematic. So we may have noticed that over here, there is a pad. So what they did was they buried the pad within the region, which is a very common practice. And in fact, we're going to do that here again in a couple of minutes when we talk about making custom pads. So there's the library for you, something to take a look at. And the reason by the way, I took a look at this a little bit closer is I was hoping to use something here that was a little more off-label. Somebody had asked me about making a spiral, which I'll show you here later on in the webinar. And I was hoping that maybe a spiral was a part of this library and I could use it, take advantage of that, but I didn't find it in here. But I figured, you know what? And a lot of people don't even know about this library. Altium spent some time putting it together. They were very excited when they released it back in 2011. And I think it just kind of got one of those, it just got shelved in a sense, because very few people even knew that they had it in here. Now, this one over here that you may have noticed, this is the one that we're ultimately going to make in the webinar today. So just, this is not a part of the MTouch, but I do have a schematic document that has a relationship, has a symbol footprint, and that's why this one happened to show up. But this is not a part of the, not a part of any of the QTouch, MTouch, CapSense libraries that you see. Okay, that's all I was going to mention to this on this particular topic. I do just have a quick polling question for you, so let's bring that one up. So just kind of know, now that you've known this or seen this over here, do you think you can make use of it, or do you plan on taking a look at it? Actually, the polling results really surprised me. I thought most people would say, well, Paul, that was kind of cool showing that for me, but all right, get on to the good stuff. But actually, a lot of you are kind of interested in taking a look at this. So I'm kind of glad we took the opportunity to show this to you. Well, very good. Well, what I'd like to do now is I want to move on to the next section of our objectives, and that is to talk about the DXF-DWG import, which I think a lot of us have struggled with. And so hopefully we can make some heads or tails out of it. I'm going to start off with a new document. This is I'm just using this one over here just because I have it ready to go. The first recommendation that I make when it comes to DXF-DWG is just open a new PCB doc. Whether you open as a free doc or you open it in your in the existing project, just go to File, go to New, and go to PCB and just open it up, because things can get a little squirrely and you don't want to in any way, shape, or form compromise what you're already working on. And if it works, we get to copy and paste it anyways. Secondly, especially if you're doing footprints or if you're doing any type of, well, what you're going to find is if you're doing footprints and you're going to involve the use of a polygon pour, you have to do it in the PCB dock anyways, because PCB libraries don't recognize polygon pours. In fact, they turn them into regions, which is a little hint is what we're going to take advantage of here when we do create our custom copper shape. Okay, so those are the two first recommendations I'll make. And then from there, in order to start this process, it is going to be File, Import, DXF, DWG. So we're going to do this, and give me a moment here while I navigate down into our project. So here is the DWG, DXF, DWG file. Given that we only have so much time today, I'm not going to go into a lot of the specifics of this particular file, but you know, it has its nuances, right? The thing is that it was created back in the 1980s. It was created in a time where memory management was really important. It is very cryptic to read. You do have to have some type of cipher in order to understand what the numbers are that they have in there. And one of the biggest issues with DXF DWG is that it was, and they did this on purpose, and I'm glad they did it, but also at the same time, it causes a little bit of confusion. They created their own coordinate system because they didn't want to be tied to either metric or imperial. And so that's why I think a lot of us, when we start going into this here, we get ourselves in a little bit of a, we get ourselves kind of a little bit wound up. So let's look at what we've got here. So first and foremost, when you take this in, you want to do this as primitives, because ultimately what we're trying to do is build a copper region. By the way, this works for silks and even for boards as well. So it's not just not strictly just for copper purposes, but a lot of times what we're trying to do is we're trying to build a mold, right? So if you ever seen somebody pour concrete and they're trying to pour it in a specific location, well, they don't just pour the concrete. They ultimately they build a boundary that they're going to use in order to pour it, and that's what we're going to do with this. So we're looking to use the primitives for that. I did play with this the other day on this drawing space between model and paper. My simple recommendation is leave it as model. I think the paper was trying to bring it in with respect to a traditional dimensions, and it just wasn't working right. So just when you're doing the drawing space, simply bring it in as a model. When it comes to the fonts, I didn't play with this too much, but if there is some writing in there and you want to use a true type font, so that would be your Times New Roman or your Arial fonts, then you could do it this way. Otherwise, it will treat it as a stroke font, which is the traditional font of the PCB layout. Another thing here, and trust me, I'm going to get to the scale here in just a moment, but let's talk about the location here. So one of the things I have found, and this has caused people a lot of pain and consternation, is that the 0, point is really tough to deal with, because for two things. Number one, there's no universal definition of an origin. We've mentioned that in the past when we do 3D library stuff. But in addition to that, a lot of times we don't work in the origin, or a lot of people don't necessarily work in the origin of their tool. So if I was to save this off, so that you can, by the way, you can also export out the DXF DWG file from Altium. But if I saved it out, I'm not working on the origin here, because actually I'm working in the Cartesian plane, or what you call quadrant 1 of the PCB layout. And so when you really, let me cancel this so we can look at this a little closer. So here's your origin here, right? And this origin is the marker for the 4 quadrants that Altium actually recognizes as a part of the drawing space. We've always worked in quadrant 1, and if you remember the old versions of Altium, like a decade ago, you couldn't even see quadrant 2, 3, or 4. And if stuff got it put into 2, 3, and 4, we had to do some crazy stuff with the list panel here. We have to go to panels, and we would have to go to the list panel. Where is that list panel? Somewhere over here, PCB list panel, and we'd have to change the XY coordinates so we could get it back into quadrant 1. When they created the 3D view, then we had more access to these other quadrants. So if something got into those other quadrants, we could grab them and pull them over if we needed to. So things got a lot easier to do that. But the fact is that we work in quadrant 1. And the reason I mention that is that a lot of people work in quadrant 1 and then they save it off. So when it comes in from that file, where's their point of reference? Their point of reference is off to the bottom left corner, not where they're working. And so that's just something to kind of keep in mind, that when we try to bring something in, it's going to be a real potluck as to what they consider to be the 0, point. Okay? Especially with mechanical engineers, unless they totally understand that. We had a customer, remember, he was getting very frustrated because he was a mechanical engineer, he's learning Altium Designer, and I show him how to do the 3D stuff, And he was like, man, they're all over the place. And I had to explain to him, it's like, look, if you're gonna draw these things in your MCAD tool, then make sure you're very careful about where you put your origin. And right after he'd figured that out, then all this stuff would just land perfectly within Altium when he was trying to do his 3D. But most of us don't think that way. So the short of it is that when we are trying to deal with this, you probably want to probably tell Altium to treat the 0 point somewhere up here in the top right corner so that there's nothing that gets into the other quadrants. And just be ready for something that might come in odd. And sometimes you just have to close out Altium, you do Control-Z to undo it. So that's just kind of my piece of advice on this. So we go back in here and let's bring this back up. The EXF-DWG, I'm going to pick this one over here. And once it comes up, sometimes it takes a little moment for it to think about it. But once it comes up, there is an option here where you can select your quadrant. So you don't necessarily have to tell it these quadrants here by typing them in. You can just select it. And I'm going to say, let's just put it over, let's put it right here for now. Now let's get into the one that I think screws up everybody. If you just took this blindly and you press OK, right, you're probably going to get something really tiny because by default, this thing comes up in mils. Right? And that's not very realistic. The one thing you got to remember is that whoever drew it must have worked in some type of system, whether they worked in imperial, they worked in metric, they must have worked in a system. It's really unlikely that they worked in mils if it has any size to it. Likely if it's in the United States, they worked in inches. And if they didn't work in inches, they may have worked in millimeters or they worked in centimeters, okay? So that's the first hint. The second thing that you may want to do is if you know who created it, ask them which scale they use. That's going to be a big, big hint. If you don't know what that is, then yes, you're going to have to play with this a little bit. And so how do we play with this? Well, one thing I wish Altium would do, this is more of a wish thing than anything else, is that they would kind of separate these things out. Because the minute we look at this, where do our eyes go? They go right to this thing called the one AutoCAD unit, and we think that this is what we're selecting over here when we hit these radials. But these first three radials over here really have nothing to do with this AutoCAD unit over here. What it's really talking about is the other. Okay, now it is kind of showing this because AutoCAD does use the units and it's kind of giving you a hint as to how it's going to translate it. But the fact of the matter is that this other over here is to allow us to do something that in case, like, for example, if they gave it into us in centimeters, we'd want to do this, and we'd want to do something like this, right, in order to do it in centimeters. But most of the time, if we got it imperial, it's probably going to be in inches, and that's all you need to do. If you really don't know what it is and you want to start really mucking with this, then you can go to other here. And yes, you could put a value in here, which I just showed, or you can just try to figure out what it is in AutoCAD units. So if I just put 10 in over here, now I'm no longer working in imperial or metric. I'm simply working in what AutoCAD unit might be. And this is where you really start looking at the sizes. And by the way, even if you're doing these, you want to look at the sizes. So if you look at this and you know what you're bringing in, and the size is too big, then there might be an issue with it, right? If you go over here and you say, like, I really don't know what that size is, but I'm going to try to guess it, then I'm going to say, all right, I'm going to put in a unit of 10. Now, the size over here does play a role. The quadrant that we work in, the first quadrant, in fact, each of the quadrants, as far as I know, in Altium Designer are 99 inches by 99 inches. But obviously, if the socket is 24 inches, I'm probably a little too big with this, and so I'd want to possibly drop it down. So this is the scale that this is where I think a lot of people struggle with it, and this is why sometimes you just don't get it right on the first shot, and that's okay. But if you can try to determine which one it's going to be, that's going to be a big help. Now, if you cannot determine it, in a couple of moments, I'm going to show you how to resize it anyways, which could help you too. And maybe you have something that's not it's like it's close, but it's not there, or you have one that's like, well, I have the 3-inch version of this, I need to make the 4-inch version of it. But you can pull in the 3-inch and you just can drag it out to the 4 to make it 4 inches. And I'll show you how to do that here. Nevertheless, this one happens to be in inches, and so that's why I'm going to set this here. Another area which kind of gets people a little bit tripped up is the layer mapping, because MCAD folks do use the layer maps, and so they put things on different layers. And it's always a potluck of what you're going to get. You don't know if they're going to give you the whole design or if they're going to give you just the socket that you're looking for. So it's the first time you run it through, you may just want to leave well enough alone. You press OK, and you realize, oh, there's all this stuff, and it's all in these different layers. Maybe I just want everything to be on a single layer. And that's what I did here, was that this one came in multiple layers, and I ultimately said, I want all mine just to come on mechanical 3 because that's where I'm going to be working. So, and that's hopefully gives you some ideas and hints to do it, but will you get it right the first time? Probably not, but at least learn what you learn from is the result of what you get from it. And so that's the way you want to kind of roll with the importer. And again, this is why I think you really want to do this on a separate PCB and not try to muck with one that you're already working with. So with that being said, I'm going to press the OK button. Let's see what we get. So you can see over here, my origin was off a bit, and that's perfectly fine. So here it is. And what I'm going to do is I'm going to do a sweep over this. I'm going to use my move select. I'm going to hit the M key followed by the S key. I'm going to click in the middle here and just kind of bring it down into this region. It just makes it a little easier to see. Another thing you may want to do is once you bring it in, if you have any type of measurements, is to do a quick sanity check to make sure the measurement is correct. So I'm just going to do first off, I'm going to make sure I'm in the right mechanical layer for this so that I can hone in on the point that I want. If I'm in another layer, sometimes I just can't hone it right into the center point. But I'm on mechanical 3. I'm going to do a Control M, check this out really quick, and then we'll just make sure that we came in clean. And if we look at the measured distance here, 350. This coordinate system they use is based on the Y distance, and so there it is. So it looks like my scaling is correct on this. I'm going to do a Shift C to remove this measurement here. Okay. Now, what if you can't get it in? It's like you've tried it, you're trying to figure out what it is. It's not the size that you want. What can we do? Well, let's do the following here. I'm going to take all this here. I'm going to do a sweep. The sweep I did is from right to left. So as long as something of that primitive is within that box, it's selected. I'm going to just delete these things here, and then we will, we'll combine this one together, and then we will take a look at how we can rescale this. Okay. And we'll sweep over this one. I'm going to do a Control X on this, and grab that one there. I could do a move select too, but sometimes I just find it quicker to just go that way. There we go. So now we've got our design. And we want to, let's say we want to rescale this. So the recommendation that I first say is that build the bounding rectangle that you want this to fit in. Now this happens to be symmetrical to square, so this would be pretty easy to do, but you might have something that's more rectangular, and you'll just have to figure out which dimensions you're going to, you got to do a little bit of scaling, right? Figure that ratio out as to how to draw that box to make sure it will fit in there. But this is square, so I'm going to draw a simple box. Here's another little trick for you may have not realized. If you want to draw a box really quick, sometimes the easiest thing to do is just change your grid so that it allows you to get from point A to point B very quickly. So I'm going to hit the G key here, and I do have to do this in the grid properties for me to move on this quickly. So I'm going to go over here and I'm going to put in 1,000, and so it's going to change my grid, and now I'm going to go into place, line, let's click over here, this one, this one, this one. Double click this and then right click it to bail out of it, and I'm going to hit escape. And so there's my bounding rectangle, and I do need to change the grid one more time, otherwise I'm not going to be able to get this in there very cleanly. So I'm going to go to a 10 mil grid. So now next step is to move this over. So I sweep over this, and again I'm going to do an MS. This is a move select, and I can do this with pretty good accuracy. Right? Actually, let me change the grid to 5 and I'll definitely have the accuracy. There we go. And now I've got this. Did not move. Let's try that one more time. MS. And there we go. I think when I went into the grid, it dropped the command. We've got it here, and I'm just going to bring this over as such. So now I've got it within my bounding box. So in Altium Designer, there is something called a union. So you can grab a bunch of things like this. I'm going to sweep over from left to right and sweep this socket here, and I can perform what is called a union. And I can do it 2 ways. I can either go into Tools, Convert. We're going to spend some time on the Convert over here throughout the rest of this webinar. And you can do Create Union from Selected Objects, which I've just done. And I can also right-click on this, and I can go into, as long as I'm on something that's selected there, then I can go into Union and do the same thing here. So that's the 2 ways to do it. So once I have a union, I can easily kind of take something and it'll come all along with it. So it's one big happy family now. I'm going to do a Control C to get it back to where it was. But now, because this is a union, I can now resize it. Now let me make you one side comment to this. In a PCB design, anything can be a part of a union, including a component. However, if you have a component as a part of a union, Altium will not allow you to resize it because obviously it does not want to change the scale of the component itself. Fortunately, everything you see over here is a primitive, and so therefore I should have no problems resizing this. So if I sweep over it, and this procedure is a little odd, you'll see the oddity here in just a moment, but follow along with me here. So I want to sweep over this. I'm going to right click on a member of this union. So in this case, this pad, right click on it and get union is the menu, and then the sub menu, I'm going to say resize the union. Well, what's the first thing it asks me to do? Well, it's kind of asking me, well, to pick one of the members of the union. So I'm going to do that again here. So I'm going to click on it, and you'll see that I now have these 4 boxes here. And all I need to do is just take that box, left mouse click, and just drag it. And I can make it bigger or I can make it smaller. And there it is. I'm going to right click off the bailout, and now I've resized it. So another way you can work this in case you're just fighting to death with the DXF-DWG and you just simply need another way of getting this to work for you. Okay. So that's how we would initially get this in through the DXF-DWG. If you have other questions about it, feel free to put those in the questions panel. Hopefully it didn't confuse you too much about it. The short, again, of the DXF-DWG is that you probably won't get it right the first time, but see what you did to get where you were and then change it up so that maybe you get it right the second or third time. Okay, I'm purposely going to go over here to continue this conversation. So this one was also the same as the last one that we imported. I'm going to take advantage of something to keep this webinar moving along a little bit. What I want to do now is I want to talk about how we're going to pour a custom pad. So in this situation here, what I want is I want a pad that goes between this inside area here and basically this outer boundary. I don't want to flood the whole thing. I just want this one square area that's going to have kind of a hollow inside to it. So what we need to do, again, as I mentioned earlier on, is we kind of have to create a mold. So the first thing I'm going to do, and by the way, there's a couple of other ways to do this. So this is not the only way to do it. But what I'm going to do here first is I'm going to actually create this to be a region. And then I'm going to select the outside area, and then that's where I'm going to pour the polygon. My recommendation is that you work on a mechanical layer first and then bring it to the top layer afterwards, or copper layer afterwards, because obviously with the polygon pour you have to have rules, and the rules are not going to work if you're in a mechanical layer because the rules don't apply to the mechanical layers. So that's why we want to start it off here, but then we're going to finish it up in the top layer. So with that, what I'm going to do is I'm going to start off with creating a region here because I want the polygon to pour away from this inside. So I'm going to sweep over this, and then I'm going to go into Tools. I'm going to go into Convert, and then from Convert, I'm going to do Create Region from Selected Primitives, and there it is. Now, I happen to be on the top layer over here, so I'm going to go to the mechanical layer, interesting. Okay, so I'm going to change this over here just to mechanical 3. So it should have been on. That's the other recommendation. Make sure you're on the right mechanical layer. Now, what's interesting about the convert, by the way, is it doesn't destroy what you already had. So if I take this and I pull it away, it's still there. So it's just taking the information and creating a new primitive. It's not deleting the existing primitive, which is a good thing because sometimes you do something like, oh, that didn't work. So you can just simply delete it and then try it again. Okay. So now that I've got this over here, I need to select the outside perimeter here. And this would probably take me about 3 to 5 minutes, and I don't want to waste your time doing it. But in order for me to basically create the outer perimeter for the polygon pour that I'm going to do, that's what I would have to do. So you just basically would have to hold down your Shift key and go, either right to left or left to right to get each one of these things. And you want to make sure that you get all of these, okay? Because if you leave these gaps over here and you try to do a tool convert and you try to do a region or polygon pour, it's gonna squawk at you. And so you really want to make sure that you do have closed lines all the way around. In fact, if some of these lines overshoot, what I have found is that Altium's okay with it. Okay? But it definitely wants to have some type of completed perimeter without any holes in it. So it's important that you select all of those when you do it. Now, as I mentioned earlier on, the reason I came over here is that I'm taking advantage of a trick that I set up before the webinar just to keep the webinar moving. This is a selection memory command. In fact, if you use the older versions of Altium, there used to be a little icon for it at the bottom right corner. Here, I'm just going to go, they still have it, they just removed the icon. So go into edit and you go into selection memory. I'm going to recall it because I've already stored it. I'm going to say 1. And now all these things have been selected here. And as I mentioned, if it overshoots this, that's okay. If later on when you pour this and you realize that these are actually problematic, then feel free to go in there and change these lines out. And I find, by the way, again, working the mechanical layers, it's a lot easier to change out these lines than to do it on the top layer where the rules are constantly getting in your way. So there it is, I have my outline. And now I'm simply going to go into tools, and I'm going to go into my convert, and I'm going to tell it to create the polygon from the selected primitives. So let's do that right now. And it will squawk at you. You'll probably find something it doesn't like, but give it a go anyway. Say yes. And I'd say 90% of the time, it'll still probably render for you just fine. Now, it did pour it. In fact, if I click here, you'll see this. And if I go into the properties, so this is one of the odd things about when you do that tools convert, change it to a polygon pour or create a polygon pour, it always gives you the none option. It doesn't automatically fill it in. So I'm going to click on solid, and there it is. Now, the thing is, you remember, there's no rules being applied to this other than the fact that I just gave it the outer boundaries. And so if I try to put this into my PCB library as is, I'm not going to get any of the benefits of the cutout or any of these other things that could be done within the PCB dock. So what I need to do now is I got to move this onto a copper layer so that the rules will be applied to the polygon pour. The easiest way to do this, what I have seen, is just select it, do a Control X. You could do a copy on it too if you want to leave the original. That's perfectly fine. You got to make sure you move to the layer that you want. Here, I want to put this on the top layer, and I'm going to go into my, there we go. I'm going to go into edit, and I need to go into paste special. The reason I want paste special is I want to paste it on the current layer. And from there, I can do paste. Now, it does come up with the colors of mechanical 3, so it does kind of initially kind of might spook you if you're not familiar with this feature. But once I place it down, it will now put it onto the top layer, and now we have a very holiday-looking, socket here. So the first thing I'll do is I'm obviously going to go into tools and reset the error markers. Now, a couple of things here for consideration. Obviously, the polygon pour pulled itself away because of the design rules. And for some of you may just say, well, that's good because I want that pull away anyways for what I'm going to need to do. But some of you may say like, well, no, I want this thing to pour all the way to the line that was created here. I want this to be exact. Well, if that is the case, then what we can do is we can go into design rules, and then from there, just simply go into the electrical clearance rule and say, guess what, guys, I want a 0 clearance. And you press OK. Now, it doesn't instantly show over here. What you're going to do is you're going to do a right click, and then you're going to have to update the polygon action. I think in the preferences, the way to auto update polygon pours, I prefer not to turn it on because if you have a lot of polygon pours, sometimes it can really exhaust your resources, your memory resources pretty quick. But from here, polygon actions, I'm going to do a repour all, and there it is. So here's where the magic begins. As I mentioned earlier on, polygon pours are not allowed in a printed on the PCB library file, but you can copy them over. What Altium does is it changes it into a region. So if I click on this and I right click and I say, okay, let's copy this thing. Okay, and I'll just take its center point right here. Let's go over to a PCB library. So I've got my PCB library set to go here. So here's my new component, and I'm going to zoom it out just a little bit. And I'm going to do a Control V. All right, and then I'm going to put this down. Now, initially it may not look very pretty, but let's see what we get out of this. And sorry, let me zoom this in so I can get this a little closer. There we go. And then voila, there it is. And what's cool about this is that this is no longer a polygon pour, it's a region, so it's fixed. Now, yes, you can go pull on some of these little vertices, which I don't necessarily recommend. I never get them to work right, but there it is. And by the way, if those little sticks did come out over here, then go back to the PCB and maybe do a little bit of work on the mechanical layer so that you don't have those things kind of come out. So there it is. Now, a couple of other notes to make of this. In the past, if you did something like this, you would have had to copy this 2 more times, one to the top paste and one to the top solder. You don't have to do that anymore. I don't know when they changed this, but I think it was a couple of versions ago. If you go here into the regions property, you just turn on the paste and you turn on the solder and you're good to go with it, which is great. So that saves a lot of time and effort. However, again, regions don't have any type of designator. You've got to add a designator to it. We do that through a pad. So we go to place and we go to pad. Here, I'm going to flip it around. I'm going to hit the tab key for a moment just to change the designator, and then we'll resume it and we can put this on here as such. Now, if you need to, you can always put pin 1 across multiple places. As long, as far as Altium is concerned, pad 1 is associated with pin 1 no matter how many pad 1s you may have, that works out rather well. And there you go. There is the footprint that you can make use of here. Okay. There's a few other notes I want to talk about with the DXF-DWG on the schematic side, because more than likely you say, well, this is a cool footprint, but obviously you need to have a symbol that's going to go along with it. So let's go back over here, this thing called custom regions. And the reason I want to bring this up is because what you saw on the PCB side is not necessarily what you're going to get on the schematic side. Okay? These are ones that I've cleaned up, and this is a component itself. That's why you saw it when I pushed the ECO over at the beginning of the webinar. Okay, well, let's bring it in because I want to show you it looks a little bit different. So let's do a file, import, DXF-DWG. And again, it's going to ask me to navigate to that, so give me a moment to get there. And let's press open. And it does take a moment or two. Sometimes it's like, well, what happened there? And there it is. So you'll notice automatically that it is not the same as what we just dealt with, right? So it's a little bit of a different creature. Now, I wouldn't worry about too much about the scale, though. By default, it always shows 0.1. Okay, and I'd say just go to 1 with it because that's going to be more realistic of what you may have here. But even if it's not perfectly scaled, remember this is a schematic, and the schematic is conceptual, therefore dimensionless. So you don't really have to worry about the scale as much as we worry about that on the PCB side of things. And also in terms of the location over here, you can select it as to where you want to put it. And so I'll just happen to put it there, and I'm going to press OK and bring it in. Now, here's the thing, and I want to show this because it was kind of a concern to me. And the Control Z does not work for this. So if I do a Control Z on my keyboard, which I'm doing right now, it doesn't move it. So the same recommendation for the PCBs holds true with the schematic. Please open up a new schematic and do this in the new schematic, and then copy it when you've got it when you've got it to the way you want it, because the Control C unfortunately doesn't work for this. The other thing too, when you bring these things in, let's assume you bring it in, it comes in great, looks good. Yeah, I can make this into a schematic, and then you'd copy this into the symbol library, by the way. And you may say, well, why didn't you just do it in the symbol library? And the reason why I didn't do it in the symbol library is I just find that the symbol library, because we work more in the center point rather than on a sheet, it seems like sometimes it gets pushed off into a weird corner. It just seems to work a lot better when I just push it into a schematic and then copy the primitives into the schematic library. So that's why I did it here and not in the schematic library. But once you've got it here and you've got it working, then feel free to copy it over into the schematic, because the primitives will copy between the schematic editor and the schematic library editor. Now, one thing that you've got to keep in mind with this, I'm going to sweep over this and notice if I go to the properties, that was 261 objects. So this looks really cool, but it's really intensive, right? Because that's 261 objects times how many properties each one of those objects has. That's really going to tax Altium. It's going to tax it in terms of memory, and it's going to tax the response as well. So just be aware that you don't always want to, if you do bring these in, you may want to clean them up or see what things you can reduce in there or simplify so that you can get the number of these objects down. So it's just not dogging down your entire project. Okay. So those are just some thoughts about this, but this is a cleaned up one, and this was just a component over here that I ultimately made with a pin on it. So there it is. So there, that kind of rounds out this idea of making the custom footprint or the custom pad for the region for the footprint. Okay. The last area that I want to jump into here with the time that I've got, I want to talk about scripts. And this came up actually a couple of months ago. Somebody asked me how to make a spiral, and I didn't really know how to go about that. And so, as I mentioned, I went to the MTouch. The individual who contacted me tried to draw this out, and it was really difficult. And come to find out, there was a script for it. And so that's my first point is, if you don't know where to go with it, go onto the Altium forums. If you're here, you more than likely have an Altium license. And if you have an Altium license, you have access to the forums. And there's well over 15 years worth of information on that forum. And the people that are on those forums, I'd say it's a very friendly crowd in general, unless you're getting a little persnickety. But if you ask for something, they more than likely have it. Or if you even search for it, you're likely to find it. And that's where we ultimately found a script for the spiral. Okay? And there are some individuals out there in this world, not just the United States, but out there in the world, who are really, really good at writing scripts. Now, if you're going to try to write a script in Altium, there's always the danger that a new version will break it. That's always been the biggest problem with scripts in Altium Designer here. But most of them, especially when it comes to just drawing lines and stuff like that, that stays pretty consistent. And you should have, there should be some stuff out there. But the first recommendation I'd make is go to the forum and see if someone already has a script, or they can point you to one that's on one of the downloadable websites for scripts and programs. And that's where we got this one over here that I'm going to show. So here's this script that's been around since 2005. It was done by a fellow by the name of Darren Moore. He's very active still on the Altium websites, pardon me, the Altium forum. And this is a script that he made that I was able to download. Again, got it through the forums. Now, when I first tried to run this, I wasn't running it right. And this is a common mistake that we make, because a lot of times the scripts, the very first thing that script is trying to do is it's trying to figure out, are you in the right editor? So what I did was I opened it up and I said, okay, I'm going to run it, and I click on run, and I won't go through the motions of this because it takes about a minute or two for it to fail it. But ultimately it's going to fail because it doesn't know what it means by getting current forward. We have to actually run it in the right editor. So for me to do this, I'm going to open this one up over here. So we'll open up the spiral test, which by the way comes with this particular project. And we're going to go into edit, and then we'll go down to run script. So as long as you have loaded the script into Altium Designer, so you unzip it and you do a file open and you do spiral track.purejscr, it's a project script. Once you've got this over here and you do file run script, Altium's going to find it in the project panel, make it available to you, and then you press OK. And now this particular script, some of them don't have it, but this particular script, the first thing it's doing is like, well, where do you want it? So I'm going to click down here, and this one does actually have an interface to it. So you can have scripts that don't, you execute them and they're done. This one happens to give you some options. So let's go with 20 layers here, probably 20 turns here, and let's press OK. And there it is, right? And so it's pretty cool. Now, what I want to do is kind of mention a couple of things to you. If I sweep over this, you'll see that these are all made of arcs. And if I go into the properties, you'll notice that there are 82 objects selecting. You say, well, that's not too many. But I did a little bit of lookup on this, and each arc has 19 properties to it. So you're effectively got over 1,500 properties that Altium has to manage. And again, it's going to slow you down. So what can we do about this? Well, the first thing to do is I'd get rid of the via. Okay. And by the way, the reason you're going to have to get rid of the via anyways is if you're going to turn this into a footprint, you're going to need to have a designator on this. And I'll show you how we can do that here in a moment. So what I'm going to do is I'm going to sweep over this, and I'm going to go back into our tools, and I'm going to go into our convert, and I'm going to tell it to make it into a region. So let's do that here. And it's going to get a little squawky with me. So it's going to say, hey, I'm going to use the outside perimeter. I'm going to say, go ahead and do so. And as I mentioned before, it doesn't destroy what you already have. It just simply creates a new one. And so sometimes the easiest thing for me to do is just pull this away here as such. Okay. And if I'm not mistaken, this one should be this. So these are the individual ones, and here it is. So how did I save us on something here? If you notice that this became a region, and yes, there are 165 points over here on this, but I'd rather have a single region with 165 properties than to deal with over 1,500 properties, right? That's definitely going to be some good memory management there. And lastly, what I want to make sure of, whether I was going to use a through hole here, which obviously would have to have through hole via, or let's say not a via, but a through hole pad. I would want to make sure that I had a through hole pad on here. And again, a pad, because a pad is a designator. And I would also want to have a designator on this as well. And by the way, it doesn't have to be big, right? So if I do a placement of this, let me go into here and I do a pad. Now this pad is huge. Well, let's go over here and we say, well, you know what? I want this designator, my dimensions here. Let's get to our dimensions. I'm just going to do this one probably like 5 by 5, and that should hopefully fit in there. Okay. And then from there, I would have to go in there and I would drop this in. Of course, I got to change my grid to something really small. And even this one's not pushing in there. So I'd have to either suspend the grid or something to do it. But the point is I would need to get this in there. And probably the better thing for me to do is just to have done this on Mechanical 3 to start with. But that's the idea behind it. Okay, but make sure you put a pad here and a pad at the end when you're ultimately doing this. So I have, I think, one more polling question for you that I'd like to know. Now that I've kind of shown these things and shown you that we can make some pretty unusual stuff in Altium, which ones do you think you might take advantage of or use in the future? And you can select more than one. Okay, yeah, I kind of figured that the vast majority of you would probably go towards the DXF custom pad route. I mean, they're kind of one and the same unless you're going to draw them out. It's good to see that a couple of you guys, a good portion of you may even give a script a go if there's something that is out there and available to you. And again, just go on the forums and ask. You'd be surprised that there are a lot of people out there that are very willing to help you out in that regard. And then for the touch sensors, I'm also surprised too. I'm glad to see that a good portion of you are interested in taking a look at that. So good stuff. All right. Well, if you don't mind, I'd like to take a moment to talk about 9.connect. So let me bring this back over here. I think I put this one to the side. I should have started where I was at. You are here for a reason. Sometimes there's an unusual footprint that just can't be tackled with the standard tool set. So everything you saw me do today, oddly enough, did not start in the PCB library. Right? We started them either in the case of the touch type of libraries, we started them in the schematic editor, or everything else I showed you was pretty much done in the PCB dock and then pushed over later on. So there are methods to custom footprints, but they're not always obvious. So maybe you found a couple of things here today that you didn't even know Altium had the capability of doing. And of course, there's a lot of nuances to these things, which you just have to practice them to ultimately understand what those are. So what do we do here at 9.connect? So there's a number of different things. We do training and we do services. So training in Altium Designer, but we also do a lot of training as of late on library management. That's where a lot of our focus and energy is, I think, especially due to the fact that there's such supply chain issues today. I think people realize that the libraries are becoming critical to some success in trying to maintain that whole situation. So we do PCB design, we do library assistance and Altium product training, simulation services, which we gave an example of last month with our webinar. But when it comes to library services, what have we been doing lately? A lot of library configuration, especially if you're working with Concord Pro or Altium 365. As we've mentioned many times before, kind of got to get that right the first time because it's a revision control system. Library cleanups, we've been doing a lot of those. And I'm going to give you a little hint. Next month's webinar, we're going to get into this. And we've done a lot of work in this particular area. I think you'll be really impressed. Even surprised at what we now have the capability of doing. I'll give you a little hint. What we used to be able to do, what I'd say in months, could be possibly reduced down by as much as 50 to 75%. So I'm just going to give you a hint to look forward to. Hope you'll look forward to the next webinar. We'll send out that announcement, and we'll definitely go into what we've been able to do to speed this whole concept up. Of course, there's library maintenance too. We've been helping a lot of customers like, look, if you clean it up, just take care of it for us because we know that we can mess you up that library pretty quickly here. And one of the big things that we do with any of these things, we don't just throw it over the wall. We actually, it's really a training. We want to make sure that if we do have to hand off whatever we need to hand off, that you know how and why we did it, and you're actually a part of this. Like, we don't just blindly send you something and configure it. We ask why, what you want and why you want this, and all the other good things too. So it's not just a one size fits all. It is very custom to your workflow. So for more information, do check us out, 9.connect. If you go into our engineering services page, you will find out more about our library cleanup services. And so with that, I know I'm at the end of the hour. If there are some questions, I'll definitely take a look at those and I'll answer those through a Q&A sheet. But look, but again, I want to thank you very much for spending the time with us this past hour. Hope you got something really useful out of it. And I hope to see you at one of our future webinars. You take care.